everyone. This is a continuation video of acids and bases. So in this video, we'll be talking about some characteristics and properties of bases, uh, knowing how to identify a basic or an acidic solution using pH indicators, and we'll be talking about neutralization reaction. So bases donate OH ions into a solution. The hydroxide group is neutralized by a hydrogen ion and water is formed. And it turns a red litmus paper into blue. Bases conduct electricity. They're slippery and caustic. So some examples of basic substances are human blood, seawater, baking soda, milk, household ammonia, oven cleaner, and drain opener. Bases often behave like bases only when dissolved in water. They're often written with symbols AQ, which pertains to aqueous or water. So the chemical formula of a base usually ends with a hydroxide or OH. So examples are sodium hydroxide and magnesium hydroxide. So how do we identify a basic or an acidic solution? Well, pH is measured by pH indicators. So if you can remember our experiment on different substances, we use the pH of a particular substance to know whether a particular substance is a base or an acid. So pH is measured by pH indicators or by a pH meter. A pH meter measures the electrical conductivity of the solution. Remember that both acids and bases are conductor of electricity. So therefore, you can make use of that property also to measure the pH of the substance. pH indicators are chemicals that change color depending on the pH of a solution. So common pH indicator is the litmus paper. The litmus paper can determine whether a solution is acidic or basic, but it doesn't give you a specific pH though. So litmus paper can only identify whether a solution is an acid or a base. So if you have a blue litmus paper turning into a red, that particular solution is an acidic solution. So you would expect that the pH of that would be below 7. And if you have a red litmus paper that turns into blue, that particular solution is a basic solution. So the pH would be considered above 7. But you wouldn't know if the pH would be 8, 9, 10, or 11, 12. So it just gives you that, well, yeah, this particular solution is a base or an acid. So that is for the litmus paper. Another pH indicator is the universal indicator. It contains many indicators that turn different colors depending on the pH of the solution. And other common pH indicators would be phenolphthalein, bromothymol blue, indigo carmine, methyl orange, and methyl red. So each determines pH within a different range. So this one here shows the common indicators and the color change of each point here. So for methyl violet, if you can see here, so it can only specify for acidic, it's yellow, and then you have blue green here, so forth. So these are common indicators, and the change of the color. So this is an indicator here. So when you try to place this one in a solution and it turns, well, I think that's orange, so most probably the pH of that solution is 3, or you would say maybe between 2 and 3. And for uh, the one at the top here, so the color changes to a dark blue. So you would expect that that particular solution is a base and the pH is between 9 and 10. Okay, so that's how a different pH indicator works. Acids and bases can conduct electricity, and the reason for that is that they release ions in your solution. So acids release hydrogen ions, while bases release hydroxide ions. So this shows here the release of the hydrogen ion in an acidic solution, and the lower one pertains to the release of your hydroxide in a basic solution. So pH of a solution refers to the concentration of hydrogen ions it has. High hydrogen ion, the pH would be low and they are considered very acidic. And if you have high hydroxide ion, the pH is high and they are considered basic. So solutions cannot have both high and high hydrogen ion and hydroxide ion. If they're mixed together, they can cancel out to form water. Such process is called neutralization. So again, you have hydrogen ion plus hydroxide ion, it will form to water. So if you want to know more about neutralization, you can visit this, you can watch this video here. The link provided in this particular slide. So again, for pure water wherein it is considered neutral, the concentration of hydrogen ion would be the same as the concentration of the hydroxide ion. And the solution is acidic if the concentration of your hydrogen ion is greater than the concentration of your hydroxide ion. While the solution is considered basic if the hydrogen ion is less than compared to the hydroxide ion. So neutralization reaction is given by this formula here. So you have hydrochloric acid mixed with sodium hydroxide. So you form water and sodium chloride. So this is just an example of a neutralization reaction. So this table here shows the properties of acids and bases. So the property pertains is shown in the first column. The second column would be the description of the acid of the particular property, and the third column pertains to the description for each property. So that ends our discussion for acids and bases. So work through the worksheets posted in the classroom, and see you next time. See you next time.